ሰላም ተማሪዎች እንደምን አላችሁ? ዛሬ ኢንተርቫልስ ኤንድ ባውንድድ ኢንተርቫልስ የሚለውን ይዤላችሁ መጥቻለሁ። Let us continue starting from intervals. Let a and b be two real numbers say that a is less than b. Then the intervals, as we are familiar, this is a to b. We call this is open interval from a to b. That doesn't include a as well as doesn't include b. Similarly, if say this a to b, this is a closed bracket. In that case, the value x between a and b and including what? A as well as b. In case, if we consider the third one, that is a open interval, this is b, including b, that includes the boundary b and all elements between them, but doesn't include, that is a. Similarly, when you consider this one, the interval includes a, but doesn't include b, but it consists all values between a and b, including a and excluding b. We call this is closed open interval or half closed interval for the case of these two. The other one, this is a closed interval, and the first one, it is open interval. That doesn't include the boundaries ብለን ያልነው ይሆናል ማለት ነው። Set bounded above means that a subset S of R is said to be bounded above if there exists a real number c, say that x is less than or equal c for all x element of S. You can take any x from S, so that values from S always less than or equal this c. C is an element of real number. We call this x is or S is bounded above the number. Similarly, if this x is greater or equal c, or in other words, c is less than or equal x for all x element of this S, the given set S is bounded below. As we said, this is bounded above. So we call this c is upper bound. As same case, if this x is greater or equal c, or c is less than or equal x for all x element of S, we can say this c is lower bound of S. Lower bound of S. From this, we can say the lower bound for this one is negative infinity to this c, we call that lower bounds. Similarly, for the case of this is c to positive infinity, we call that upper bounds. From this upper bound, at the same time, this is lower bounds. From the upper bounds, the least upper bound from this, least upper bound from this, that is c, we call this is the least upper bound. Similarly, we can say this is the greatest lower bound. This is the greatest of all from this interval. So in this case, we try to derive or find the greatest lower bound and least upper bound of the given set that we have S, which is a subset of R. You can consider these intervals. Here it says 1 to 2, it is open interval, it is closed interval, it is half closed interval, closed open interval. These are both cases, these are bounded below as well as they are bounded above. It cannot be less than 1 in the case of this, it cannot be less than 1 here also, cannot be less than 1. It is approaching to 1, or it may be some values which is greater 1. So we call this is bounded above, and we call this in general, these are bounded set. We call it is bounded set. It is since bounded set. Why it is bounded set? Since it is bounded above as well as bounded below. Because of this, we call such types of set is bounded set. If we consider every finite set is bounded, if we have any finite set that we have, so it is bounded. Since it is restricted, it is known that it has lower upper bound as well as the lower bound as well as the upper bound. That means it is bounded. If it is bounded, and every finite set is bounded, both below as well as above. You can consider set this 1 over 2, 1 over 3, 1 over 4, it is continued like this. What does it imply? This implies that the value goes to what? 0 to 1 over 2. It means it includes 1 over 2, but we say that 1 over 3 is less than 1 over 2 and 1 over 4 is less than 1 over 3, and if it continues like this, so this value approaches to 0, but not exactly equal to 0. So it is bounded. It is bounded. And from this, we can determine the greatest lower bound as well as the least upper bound from this. The greatest lower bound means what? Which is the one on the left side, which is minimum of this. What is that? That is 0. 0 is the greatest lower bound for this one. What about least upper bound? From the upper of this, it is 1 over 2 to positive infinity, they are upper bound. Negative infinity to 0, that is lower bound. From the lower bound, the greatest of all, that is 0. From the upper bound, the least of them is what? That is 1 over 2. Let's say this is set S. If you consider this one, you see, this greatest lower bound 0 is not element of our S. But when you consider this half is element of S. So, the least upper bound or the greatest lower bound may be element of S or may not be element of S. ሊሆን ይችላል የኤስ ኤሌመንትም ሊሆን ይችላል የኤስ ኤሌመንትም ላይሆን ይችላል ማለት ነው። What is that? Least upper bound as well as greatest lower bound of the given set. So the least upper bound sometimes we call that is supremum, and the greatest lower bound we call that is infimum of the given set we have. You can consider different example for this. If we have S is equals to 1 over n, n is element of natural number, then what is S? We can denote this S other forms, which is when you say that 1, it is 1. When you take 2, 1 over 2. When you take 3, this is 1 over 3. When you take 4, it is 1 over 4, and it continues. So this value becomes what? When x, this n goes to positive infinity, the value approaches to 0. So it is equal to 0 to 1. Including what? 1. Is it bounded or not? Yes, it is bounded. From this, what is the least upper bound for this one? From the upper, that is 1. 1 is element of S, as well as it is the least upper bound for this S. What about the greatest lower bound for this one? That is 0. 0 is the greatest lower bound for this S, but it is not element of S. So, the least upper bound and greatest lower bound may or may not be element of S. You can consider this S 0 to 1. Then, what's the least upper bound for? That is 1. 1 is the least upper bound, but it is not element of S. Similarly, the greatest lower bound for this one is what? GLB for this one is equals to, that is 0, but which is not element of our S. If S is finite set, then the LUB of S is what? Largest element, and it belongs to the set. If the greatest lower bound of S is what? The smallest element, it belongs to what? The given set S. You have to take different example for this one. Let's take this S is equal to 1, 2, 3. You see, if it is bounded and if it is finite on this interval, yes, the value is what? Between 1, 2, 3. Even if you have infinite values in between them, but from this, what is the greatest lower bound? That is the largest of all. That is 3. 3 is the least upper bound for this thing. Similarly, this 1 is what? The greatest lower bound of S, which is the smallest of all. Let us see this one. Find the LUB and GLB if they exist for the following sets. It says. To find this one, let's take the first one. The set becomes consists of the form. When you take 1, 1 minus 1, that is 0. When you take 2, it becomes 1 minus 1 over 2, that is 1 over 2. When you take 3, it is 1 minus 1 over 3, this is equals 2 over 3. And it goes like this. If you take that is 4, it is 3 over 4, and it continues. See? When you consider this one, this is equal to the interval as n goes to positive infinity. Let's take this is an is equals to 1 minus 1 over n. As this n goes to positive infinity, what the value of a? An approach to what? Approach to this becomes 0. So 1 minus 0, that is 1. It consists 0 to 1. It is open for the case of 1. You see, as n goes to positive infinity, the value of this approach to 1. Why? Since this 1 over n approach to 0, as n becomes a very large number. In that case, this set or this sequence or this set goes to the form of interval 0 to 1. From this, you know, the smallest of all that is 0. The upper one is what? Including 1 to positive infinity. From this, what you observe? What is LUB for this one? LUB of our set is equals to that is 1. But it is not element of what? Our set. But it is not element of the given set. የሴታችን ምን አይሆንም? element አይደለም. That's one. What is the GLB greatest lower bound for this one? That is 0. 0 is what? It is element of our set. This is the element of our set. So we can determine like this. We can find the others in similar way. Let's try to continue the next one. It says that let's take our AN. This AN sequence, which is equals 3n plus 2 over 2n plus 1. You can take the values as take n is equals 1, that is A1. A1 is equals to the value. Substitute 3 times 1, that is 3 plus 2, that is 5. 5 over what? 3. Let's try to continue. A2 means, which is equals 3 times 2, that is 6. 6 plus 2, that is 8. 8 divided by 2 times 2, 4. 4 plus 1, that is 5. Let's continue. What about A3? A3 is equals, take 3. 3 times 3, 9. 9 plus 2, that is 11. 11 over 3 times 2, that is 6. 6 plus 1, 7. Similarly, next one, A4. When substitute 4, 3 times 4, 12. 12 plus 2, that is 14 over 4 times 2, that is 8. 8 plus 1, that is 9. And when this n approach to positive infinity, let's take this as n approach to positive infinity. What is the limit of this one? Limit of an as n approach to infinity is goes to what? Since it is infinity over infinity, we can find this. The limit of this one, 3n plus 2 over what? Over 2n plus 1 as n approach to positive infinity. Since it has infinity over infinity forms, we can divide each term by n, the highest degree of the denominator, which is equals the limit of this 3n divided by n plus 2 over n is divided by 2n over n plus 1 over n as n approach to positive infinity. Now what the value now? This is equals, which is equals to limit, this is 3 plus 2 over n over 2 plus 1 over n as n approach to positive infinity. When you consider this one, this approach to 0, at the same time this also approach to 0. Then what the result? This is equals to 3 over 2. So this value approach to 3 over 2, this is 1.5. What about 5 over 3? 5 over 3 means you can divide this one 5 for 3. This is 3. 1 times 3, that is 3. Then subtract this one. 5 minus 3, that is 2. Then give point here, wow. Then add 0 here. 20 divided by 3 is what? That is 6. This is 18. Again 2 and 0. It is 6. But 3 over 2 means what? 1.5. So it is decreasing. And this decreasing and decrease approach to us 3 over 2. So when you express this at the form of the interval, it becomes open interval 3 over 2 to 5 over 3, including this one. From this, we can determine the least upper bound as well as the greatest lower bound for this one. What is LUB for this? LUB of this is equals to 5 over 3, the greatest of all. Similarly, GLB for this is equals to what is that? 3 over 2. So we can determine the LUB and the greatest lower bound of the given sequence by observing the pattern of our sequence, whether it is increasing or decreasing. If it is increasing, you will try to determine the first and the last one as n goes to positive infinity. Similarly, if it is decreasing, you have to take some terms of the first and take the limit as n goes to infinity, what the sequence looks like. After that, you will try to determine GLB as well as LUB of the given set. እዚህ ጋር LUB እና GLB ማለት greatest lower bound እና least upper bound ለመፈለግ የተሰጠንን ሴት ምንድነው የምናየው? ፓተርኑን እናያለን። If it is increasing ከሆነ you will see some terms, the first and the next term observe እናደርጋለን. After that, try to take the limit as n goes to positive infinity. የሲኩዌንሳችንን ሊሚት እንወስዳለን as n goes to positive infinity. In that case ያገኘነው ሊሚት ምን ይሆናል? ኦፕን ኢንተርቫል ይሆናል ማለት ኢንተርቫላችን የመጀመሪያውን ተርም ይዛል የመጨረሻውን ግን it approaches to that number ስለሆነ limit ስለሆነ የወሰድነው as n goes to infinity it becomes open interval. From that, the minimum of that means the first one that is 0 like this ምን ሆነ the greatest lower bound ሆናል and the limit as n goes to infinity ያገኘነው value ምን ሆነ the least upper bound for the given set ይሆናል ማለት ነው። Similarly, if the sequence or the set is decreasing ከሆነ sequenceአችን የመጀመሪያዎቹ የተወሰኑ ተርሞች እናይና pattern looks like that one whether it is increasing or decreasing መሆኑ observe እናደርጋለን። After observing that, you'll try to find the limit of your sequence as n goes to positive infinity ሲሆን የምናገኘው ሊሚት ይኖራል ማለት ነው። So, if it is decreasing ከሆነ እዚህ ጋር lower bound የሚሆነው 3/2 for instance lower bound ነው open interval ይሆናል። ነገር ግን upper bound included ስለሚያደርግ it is closed ሆነ half closed ሆነ። From that, you will try to identify the LUB as well as GLB of your set እናደርጋለን። ያን ስንሰራ you can find in such a way በዚህ አይነት መንገድ እናገኛለን ማለት ነው። Let's try to continue to the next one. It says that x says that -5 is less than x is less than 3. As we said before, this means you can find what? The upper bound for this is equals to 3 to positive infinity we can say, and its lower bound for this set is negative infinity to that is -5. So from this you'll try to take what the upper one that means LUB means the least upper bound for the given set is equals to that is 3. The least of all is it is 3 to positive infinity. From this which one least of all? The least of all that is 3. Similarly the greatest lower bound for this one from the lower bound which one is greatest that is -5 we can say. So we can find LUB and greatest lower bound from the given set like this, or you can take the one which is minimum of this that is -5 but not included in this interval, so it is not the set element of set ግን አይደለም -5. Similarly 3 is not the element of our set የኛው s ብንለው ሴታችንን this implies that 3 is not element of what the given set s. At the same time the greatest lower bound that is -5 also is not element of our set s. So least upper bound as well as greatest lower bound may be element of the given set or it may not be element of given set. የሴታችን አባል ወይም ኤሌመንት ሊሆን ይችላል ወይም ላይሆንም ይችላል ማለት ነው። ከዚህ የምንወስደው ይሄንን ነው። always element of the given set ላይሆን ይችላል ወይም always ደግሞ element of a given set ያልሆነም ላይሆን ይችላል ማለት ነው። ስለዚህ it can be ሊሆንም ይችላል ላይሆንም ይችላል። Let's try to continue to the next one. It says that x says that next one says x says that x is equals 1 plus 1 over n is element of natural number. It says that means our sequence that means an is equals to 1 plus 1 over n forms n is natural number. From this you will try to find the first terms. The first one if you consider a1 which is equals 1 plus 1 plus 1 over 1 which is equals 2. What about a2? A2 is equals to, when you take this 1 plus 1 over 2 is equals to 3 over 2. What about A3? A3 is equals 1 plus 1 over 3. 1 over 3. The result is equals to 4 over 3. What about A4? A4 means 1 plus 1 over 4 which is equals to 5 over 4. After this, is it increasing or decreasing? It becomes the first one 2 and 3 over 2. I think it becomes what? In form of decreasing. It decreases. So let's take the limit as n goes to positive infinity. Let's try to take the n value what? An approach to what? Where it approaches? This value 1 plus 1 over n. So it approaches to what? Where it approaches? This becomes 0, then it approaches to 1. So since it is decreasing and approach to 1, so the given set doesn't include 1 there. So this goes to, or it looks like what? The interval consists 1 to 2, including this 2. So whatever the value we take, this value of this set lies what? Between 1 and 2, including the upper one, that 2. From this, what is LUB for this one? LUB, that means the least upper bound. From this, you have to take the greatest of all. That is the element of our set, it becomes. So that is 2. What is the greatest lower bound for this? Greatest lower bound of this is what? 1. It is not element of our set. So we can determine such forms. Similarly, let's try to find next one. It says x is that x is equals to the power of n is element of integer. From this, what is an? Our an is equals to the power of n. And when you take n starts from 1, which is 2. When you take the second a2, which is equals to 2 square is equals to 4. Let's continue. What about a3, which means 2 the power of 3 is equals to 8. When you take that is 4 is equals to 2 the power of 4 is equals to 16. And it goes to this 4. So as n goes to positive infinity, what the value of an? This an is equals to the power of n goes to positive infinity. What does it imply? What's above. That means we can't say this is bounded. It is bounded below, but not above, since it goes to positive infinity. And in general, we can't say this it is bounded. Yes? It is not bounded. So from this, since it is bounded above, no? Bounded above corner, we have what? This implies that we have LUB. The least upper bound for this one is what? Negative 2 lemon. This is equals negative 2 to positive infinity upper bound هنا. From this upper bound, which one is the least upper bound? That is negative 2 هنا. እዚህም ጋር ስንመጣ 2 to positive infinity ነው. From this, what the lower bound? Lower boundaችን ሆነ negative infinity to 2 ይሆናል። ይሄ ማለት ምን ማለት ነው? Which one is the greatest of all? That is 2 የሆነበት ምክንያት ይሄ ነው ማለት ነው። በዚህ አይነት መንገድ least upper bound እና greatest lower bound ማግኘት እንችላለን። ስለዚህ if it is bounded below ከሆነ we have greatest lower bound ይኖረናል። If it is bounded above ከሆነ we have a least upper bound ይኖረናል። Man for any set we have. Other one, let us see it. It says that x is equals negative 1 to the power of n is element of natural number. This means which is equals to ይሄ ምን ይሆናል ማለት ነው? negative 1 if n is odd ከሆነ negative 1 ይሆናል and 1 if n is even. The set is equals to negative 1 and 1. Consists from this, which one is the upper one? The upper one is what? The lower one is what? Negative 1. From this, we have the least upper bound. All this is equals to 1. Why? Since 1 to positive infinity is its upper bound. We have a mono that upper bound for this natural one. Similarly, it is greatest lower bound is equals to. Let's try to continue to the next one. Similarly, we can find this. This says that 1 over 5 n is element of integer n different from 0. If we consider this, start from 1 and negative 1. If say n is equals 1 for instance, it is 1 over 5. When you take here n is negative 1, it becomes negative 1 over 5. Similarly, if we take here is n is equals to, that is 2, and let it be our an is equals 1 over 5n. N is equals this one. What for? This is a2 is equals to 1 over 10. Similarly, same n is equals negative 2. Here is equals negative 1 over 10. Let's try to compare and contrast them. When n is 1 over 5. When n is negative 1 over 5. When compare and contrast this one, what the value? 1 over 10 is, which is equals, expressed in the form of ratio. This is 0.2, which is equals negative 0.2. Similarly, this one 0.1. This is equals negative 0.1. And continue like this. Let's say this is n is equals, for instance, that is 3, which is equals 1 over 15. Similarly, n is equals negative 3, which is equals negative 1 over 15. and continue like this. Here is n is equals 4, what for a is equals to this, a for whatever the case is equals to 1 over 20. Similarly, if n is equals negative 4, this value a is equals to negative 1 over 20. I think it goes toward the way of decreasing this. In case of negative, it is increasing, since a smaller negative is greater than the greater one in case of its magnitude. So, in general, as n goes to positive infinity in both cases, whether it is negative or positive, as n goes to positive infinity, this an approach to what? That is 0. So, this interval lies in between what? The interval, this lies between negative 1 over 5 to 1 over 5. It becomes on this interval. It includes both. Since you have to consider on the number line, here you have if the xy plane. Let's say here is negative 1 over 5 means, let's take here is negative 1 over 5. The other one, here you have 1 over 5. And when the other 1 over 10 means what? That is less than 1 over 5. In between somewhere is. Similarly, negative 1 over 10 means what? Somewhere in between this. So when you take 1 over 50 also what? It is less than or approach to what? Toward 0. The same for the case of what? It approaches to 0. So as n goes to a large number, its value approaches to 0. That 0 also obtained what? Between negative 1 over 5 and 1 over 5. Therefore, from this, what is the LUB for this set? LUB is equals to 1 over 5 and its elements so far. That's given set. የሴታችን element ይሆናል። Similarly, what about our GLUB is equals to negative 1 over 5. Still, it is element of the given set ይሆናል ማለት ነው። So, we can find elements of or the greatest lower bound as well as least upper bound of the given set like this. በዚህ አይነት መንገድ የሌሎችን ፕሮብለሞች እንሰራለን ማለት ነው። ምንድነው የምናየው? As we did before, you try to see the pattern of your sequence, whether it is increasing or decreasing. Patternun ካየን በኋላ you try to find the limit as n goes to positive infinity, and you looks like what the value becomes. ያንን ካወቅን በኋላ you try to identify the intervals in which all the values that you have lies. እነዚህ ኢንተርቫሉን እናገኛለን። ላይ የሚያደርጉ በሙሉ ስናያቸው በኔጌቲቭ 1/5 እና በ1 over 5 መካከል ይሆናል። From this interval, the greatest of all ማን ይሆናል? greatest lower boundation negative 1 over 5 ይሆናል, or the least of all ማለት ነው። Similarly, the least upper bound means 1 over 5 ይሆናል. That means the least of all the upper bound you have. In other words, upper bound የምንለው 1 over 5 to positive infinity upper bound ይሆናል. From that, which one is the least of them ይሆናል። Similarly, negative infinity to negative 1 over 5, it is what? Lower bound ይሆናል. From the lower bound, the greatest of all is that is negative 1 over 5 ይሆናል. Because of this is LUB 1 over 5 and GLB negative 1 over 5 ብለን በዚህ አይነት መንገድ እናገኛለን the pattern of your sequence. That means whether it is increasing or decreasing. In case of increasing, you'll try to find what? The first one or two terms. And finally take the limit as n goes to infinity, what the sequence looks like, where it approaches. So, since it is increasing, we make this limit as open interval. If the first term is, for instance, A, the upper one is B, so make this is open. From this, the greatest of all, since the lower bounds are what? Negative infinity to A, so this A is equals to the greatest lower bound of our set. Similarly, B is not in the given set, but it is B is equals to the least upper bound of our set we have. Similarly, for the case of this decreasing, as we said before, in case of increasing, you'll try to find first terms, some terms of the first one. So, that term shows us the way of decreasing our sequence. የሚያክል ወይም እንዴት decrease እያደረገ እንደሚሄድ የሆነ hint ይሰጡናል ማለት ነው። And finally, you'll try to find an as n goes to positive infinity, what value of the sequence an approaches. From this, if some terms of the first term maybe, for instance, that is B, and as n goes to positive infinity, a n may goes to what? A. As n goes to positive infinity, let it be, that is A. Since it is decreasing, we have the intervals for this one. This shows that the whole system approaches to on the interval that is A to B, including B, but doesn't include A. Lemon, as an goes to A when n goes to positive infinity. That means it is approaching, so it doesn't include what? The value is A. Because of that, we make this open interval at A and including B. So we have half closed interval or open closed interval we have. From this, what is LUB for this one? LUB becomes what? That is B. And this B is also what? Included in the given set. The set is just included. So the GLB of this set is equals to A, but it is not element of the given set. ስለዚህ በዚህ አይነት መንገድ እንሰራለን ማለት ነው። ምንድነው የምናደርገው? የመጀመሪያዎቹን ፓተርን እናገኛለን፣ ዘን ሊሚቱን እንፈልጋለን ሲኩዌንሳችን n goes to positive infinity ምን እንደሆነ። ስለዚህ ኢንክሪዚንግ ነው ዲክሪዚንግ የሚለውን ካየን በኋላ ኢንክሪዚንግ ከሆነ የመጀመሪያው ተርም ምን ይሆናል ማለት ነው? the greatest lower bound ይሆናል። ላስት ዋን አፕሮች ያደረግንበት ኦፕን ኢንተርቫል ሆኖ ኢንተርቫላችንን ኢንክሉድ የሚያደርገው ወይም ኤሌመንት ኦፍ a given set አይሆንም but it becomes LUB ይሆናል ማለት ነው። For the case of decreasing also you will try to find some term እናገኛለን። some terms እናገኝ የመጀመሪያው ተርም ከሁሉም ከአዘር ተርሞች ይበልጣል። ለምን? decreasing ስለሆነ። so as n goes to positive infinity an ስናገኝ ሊሚቱን እናገኛለን። so the interval between what? The limit and the upper bound that is B ይሆናል ማለት ነው። በሁለቱ ኢንተርቫሎች መካከል ይሆናል። ነገር ግን የመጀመሪያው ተርም the upper one is the greatest of all ስለሚሆን it becomes LUB of what? The given sequence ወይም ደግሞ the given set ይሆናል። GLB ምን ይሆናል ማለት the limit that you obtain ሊሚቱ as n goes to infinity an ያልነው የn value a ነው ስላል that is the greatest of bound for our set one. Now let's summarize it using the bound formation. If we consider the given set S is equals to -1 the power of n over n minus 1 as n is an element of natural number, we can consider this simple instance. So when observe this, you will see some patterns if you want. Let's say this is an is equals to -1 the power of n divided by n minus 1. This shows that what is a1? a1 is equals to -1 minus 1 which is equals -2. When you take 2 n2 which is a2 is equals -1 the power of 2 that is 1 over 2 which is 1 over 2 minus 1 which is equals -1 over 2. When consider that is a3 which is equals to -1 over 3 minus 1 which is equals -4 over 3. Let's try to find this is a4 n is 4 which is equals -1 the power of 4 that is 1 over 4 minus 1 is equals to -3 over 4. And we can continue with this pattern. If we continue in this way, what we have? This S is equals to 2 cases we have. When n is odd, this becomes -1 over n minus 1 if our n is odd. n ናችን odd ከሆነ it becomes -1 over n minus 1 ይሆናል። Similarly, if n is even, -1 the power of n that is 1 over n minus 1 if our n is even. This means we can express this other forms even and odd. This is equals to -1 over 2n minus 1 minus 1 over 2n minus 1. We can express for n is element of natural number. This is equals for n is element of natural number. We can express such forms. Even means what? 1 over 2n. Odd means -1 over 2n minus 1. After obtaining this, you will see some terms here. a1 that is -2, a2 that is -1 over 2. Here is -4 over 3, -3 over 4. All this approach to -1. Let's see the limit for this one. As the value of n approach to positive infinity, what it selects like this one. This implies the set which consists this one approach to 0 and then it is -1. Similarly, as n approach to positive infinity 1 over 2n approach to 0 minus 1, it is what? -1 still. So this sequence Sn or S is equals to -1. Therefore, when we observe this, which one is the least? The least is -2. Which one is the highest? The highest is -half. So, the set this S lies on the interval that is including -2 and including -half. Since the other values lies in between, you have to say this one. -4/3 is what? -1.33. It lies between them. -3/4, that is -7. 0.74, 0.75, it lies in between. -1 also lies in between. Therefore, from this, what is the greatest lower bound of our S is equals to, that is -2. And the least upper bound of our S is equals to what? This is -half. This implies that both are element of S. This is an element of our S. This also element of our S. We can find the least upper bound as well as greatest lower bound of any set we have in these forms. Let's add one more example on this. Let's say this is, let's be set A is equals to consists, which is equals to 1/2n plus, let's say this is 3, 4, n is element of, let's take this is integer n. N is different from 0. We can say this. When we observe this, how the value looks like. This is equivalent to, if say let it be an is equals to 1/2n minus 3. When you take 1, this is a1 is equals to 1/2 minus 3, which implies, which is equals to -5 over what? That is 2. Since here is 1 minus 6 means -5/2. Let's take 2, a2. a2 means here is 1/4 minus 3, which implies -11/4. And we can continue like this. What about a3? a3 means 1/6 minus 3, which is equals to -17/6. You can observe this. As n goes to positive infinity, an approaches to what? This value 1/2n approaches to 0, then it becomes -3. What do we observe this? Is it increasing or decreasing? As we observe here, -5/2 means what? -2.5. -11/4 means what? It is -2 point. When you take, here is 3/4, that is 7/5, and it continues. And approach to what? Approach to, here is -3. This means it is decreasing. If it is decreasing, we have the first interval included in the given set. This is -2.5 or -5/2, but we may not include this -3. Since it is the limit, it is open on this interval. So our set A consists the interval, which is -3 to -5/2, including this one. Or if you want, which is equals -3 to -2.5. Since -5/2 means what? -2.5. From this, we can observe that what is, therefore, from this what form? LUB of our set A is equals to -2.5, or which is equals -5/2. You can say. Similarly, what about GLB of our set A is equals to, which is equals -3. You see, -5/2 is element of set A, but -3 is not element of set A. So we can find the LUB and GLB of what? Any given set in these forms. ስለዚህ ቻናሉን ሼር፣ ላይክ፣ ሰብስክራይብ ማድረጋችሁን አትርሱ። ለሌሎችም መድረስ ስላለበት ማንኛውም ጥያቄ ካላችሁ ኮሜንት ላይ አስቀምጡልን። እንሰራለን፣ እናብራራለን። ኦንላይንም ላይ በመግባት የምትፈልጉትን ጥያቄ መጠየቅ ትችላላችሁ። በዚህ አይነት መንገድ እነዚህን እና የመሳሰሉ ጥያቄዎችን እንድትሰሩ እንጋብዛለን። አመሰግናለሁ።